All right, so I just wanted to go over these two a little bit more complicated examples, and then get into some applications. The applications themselves, the word problems, they really just boil down to just pulling coordinates and other bits of information from the word problem in order to make a piecewise function and evaluate that piecewise function, right? But for now, it's just a matter of writing the equation. So we have three pieces to this one, all right? So looking at this, if we were to draw a number line at the top, and you don't have to do this, but reasonable enough strategy. We have a cutoff from the first piece. Let me go in order here. First piece to the second piece happening at -1. Then another cutoff or a break in the graph happening at +1. All right, at which point it transitions to the third piece. All right, so we're looking at this, and this representing the domain. It's just a question of how they join together, all right? So we have a closed circle for the first piece, and then a couple of open circles for the second piece, and then a closed circle for the third piece, all right? So we have to account for that, all right? So because of the closed circle, I would say that the first piece has a domain of x is less than or equal to -1, all right? So it's definitely lower than -1, right? Here's -1, here's -infinity. It's all of these values over here, but it also includes the -1, so that's why it gets the equal sign. The second piece goes from -1 to 1, so that would be, but it doesn't include the -1 or the 1, so -1 is less than x, which in turn is less than 1. All right, so that would be the second piece. And the last piece starts off at 1 and then increases without restriction. All right, so it goes off to infinity. Another way of saying that would be x is greater than or equal to 1. So these would be the domains for the three pieces. Now again, the number line thing here is really just for instructional purposes. I mean, if you happen to have a highlighter and want to do it this way, that's perfectly fine. I mean, it's not something you'll be able to do in the Regents, but if it helps get the idea across, that's the plan anyway. But now what I want to do is write the equation of each line. So I need a slope and I need a y-intercept for each one. The only one that obviously has a y-intercept, and by obviously I mean it's right on the graph, is the middle piece. But we can infer the y-intercept for the first and the third piece if we extend. All right, the first piece has a slope. Well, actually, they all, if you look carefully, you'll see each one of them has a slope of 1, up 1 over 1. And that should make sense. Well, maybe not necessarily the one part of it, but the fact that they all have the same slope, because they're all pitched in the same direction. All right, so we have a slope of 1 and a y-intercept of 2 for the first piece. For the second piece, I have a slope of 1, a y-intercept of 3, and for the last piece, I have a slope of 1 and a y-intercept, well, it would be 0 if it got there. All right, so now the only thing that we have left to do is just to piece it together in the appropriate fashion. All right, in the homework there was a trick question. I don't like doing this, but the Regents folks do it, where they put the domains out of order. An appropriately framed piecewise function always has the lower domains first, then it increases beyond. So we work from left to right across our domains. Right? So I have 3 pieces here, so I want to open a squiggly bracket sufficient to accommodate 3 pieces. The first piece, 1x plus 2. I'll say if, and that has a domain. The green domain is x is less than or equal to -1. The second one, 1x plus 3, if the second domain is between -1 and 1. So -1 is less than x is less than 1. And the last piece, 1x plus 0, if x is greater than or equal to 1. All right. You're not always going to be asked to simplify, just be prepared to. In this case, it's not really that big of a deal. In fact, if you just look at it, it's really just a matter of getting rid of the 1s and this 0. Right? Not much to simplify. All right. So, you know, and some people, I mean, early on, some people can do this without marking up the graph at all. I mean, that's great. I think that's something to work towards. It's not the expectation that you're there already, but you know, like if you can get there, that'd be good, especially by the time you get into Algebra 2, because being able to plot graphs without having to create a table of values and mark things up, you know, it's a useful skill. All right. For number 10, still 3 pieces. All right. So again, we want to look at what the domain would be for each piece. So where the graph changes. So we have 3 lines here. We have the first line has a positive slope, the second line, that's the 0 slope, and the last line has a negative slope. All right, so again, I'll just use that number line approach. So -2 is when there's a transition from the first piece to the second, and +2 is when there's a transition from the second piece to the third piece. All right, so 1, 2, 3. All right, so the arrows tell us that we're looking at all values of x that are less than, and there's no open circles here. All right, that's something to be mindful of. Now, again, I think I mentioned this yesterday, but I apologize if it was for a different class. Just because there aren't any obnoxious points, like bolded points there, doesn't mean that you treat this any different than if there was an obnoxiously large point there. All right? So it's the lack of an open circle that indicates that we have a real point there. All right? So we have definitely a point here. If you want to mark it up, you know, put a solid point there as just kind of like a visual cue. That it's not a bad idea, but it's not necessary. All right. So all values of x that are less than or equal to -2, less than or equal because there's no open circle. All right. That's our -2 right here. All values of x between -2 and 2. That's our middle piece, and all values of x that are greater than or equal to 2. That's our third piece. All right. Then we just need to come up with the slopes and y-intercepts for each one. Easier said than done in some cases, because if it doesn't trend to a point that's actually on the graph grid, you might have to extrapolate, but you know, it's not always necessary. But you could definitely figure it out. It's just, it might be time consuming. But the middle one is pretty obvious. We have a slope of 0, and the y-intercept is equal to 2. It's the first and third. I mean, we can count the slopes, but the y-intercept, you know, we'll have to be careful about that. We have a clean point right here, a clean point right here. We have one here. You just need to find the slope between any 2 consecutive clean points. All right? So I'll take these 2 clean points. So up 3 over 1. So we have a slope of 3, rise over the run. All right? Now I just need the y-intercept, which is what you would get if you follow that same trend. All right? So let me move this for a sec. So I'm going to go up 3 over 1. I'm still not at the y-axis. So I need to go up 3, 1, 2, 3, over 1. So that's where my y-intercept would be. So that's 1, 2, 3, 4, 5, 6, 7, 8 points up. All right? So I had to extrapolate where that point would be. It's the only time on this page where that happened. Now, if we were, let's say that the last point that we were given was 20 units to the left of the y-axis. We might have to do a lot of extrapolating. Okay, add 2, add 3. Well, in this case, the slope is 3. Add it how many times? Well, how many spaces are there between the point and the y-axis? You know, that's what you'd have to figure out. But we'll tackle problems like that in a little bit. So 8 would be our y-intercept, just by counting where the box, or where the point would be if the boxes were there. All right. Now this looks like it has symmetry. My suspicion is that this is going to be a slope of -3 and a y-intercept of 8. The reason I think that is because it's symmetric on the down slant. It looks like it has the same pitch, but in a downward direction. So that would be the case of just negating a slope. And it looks like it's aiming for the same point. But I'll verify, because I'm not going to just guess and hope for the best. So I'm going to get 2 clean points. I have 2 clean points. Yep, there's a slope of 3, up 3 over 1. But over 1 to the left. So we have the 3 here, we have a -1. Follow the same trend, up 3 over 1, up 3 over 1 brings you to the same place. All right. So now we have all the information needed to write the equation of this piecewise function. All right, so f of x, again, 3 pieces. We have 3x plus 8 if x is less than or equal to -2. 0x plus 2. You could write that, or you could just write 2. If x is between -2 and 2. And then -3x plus 8 if x is greater than or equal to 2.